This is a pretty timely subject because we've just had a new refresh of the SSURGO data for FY2015, so I know there'll be a lot of interest in how to obtain the data and some of the things that you can do with it. Today's webinar is primarily focused on those folks that are responsible for maintaining large collections or archives of SSURGO data, or who are interested in learning how to use the relatively new gSSURGO geodatabases. And we've got some contact information for both Sharon and myself. I'll be taking the first part of the presentation. We've got about 60 slides, so we're going to go through these fairly quickly, and we're going to ask you to hold questions at the end. But if you notice on each of the slides, there is a slide number. So if you have a particular question that pertains to a particular slide, just go ahead and make note of that, and that way if we need to, we can run back to that slide. Sean said that, told you I was a GIS specialist. I'm here at the National Soil Survey Center on the interpretation staff under Maxine Levin. And Sharon, do you want to say something real quick?
Sure. Hello, everyone. My name's Sharon Waltman. I'm a soil scientist here with the National Soil Survey Center, so I work for USDA NRCS. I happen to be on a little special location at a geospatial research unit located at West Virginia University in Morgantown, West Virginia. So I guess I've been working with the National Soil Survey Center for nearly 23 years now, and probably almost 20 of those with Steve. So we've been doing this work together for a long time. So I'm pleased to be able to work with you today and talk to you a little bit more about a little different product called the gridded SSURGO. So I'll be talking about the second half of the webinar. Go ahead, Steve.
Thanks, Sharon. Okay, this is a short outline of some of the materials or information we're going to be covering during the webinar. I'm going to start out talking about some of the ArcGIS, the custom tools that we use to obtain the data when we're looking at downloading large numbers, thousands or hundreds of SSURGO data sets. So we're going to actually make those available to folks that want to do this on their own. And then we're going to talk, Sharon's going to talk about the official gSSURGO product and talk a little bit about the official release of the data because last few years have been trying to keep the updates to this data on an annual basis so people don't have to worry about continually having to check for new data. And then she's also going to talk about a very important product called the National Value Added Lookup Table Database, which is a companion database to the gSSURGO. And also going to discuss briefly some of the exceptions to those update rules. Right now we're in the process of updating all of our data, and most of that actually took place at the beginning of October, but there were a few states that found some issues with their data after they posted it. So we're going to talk a little bit about how to find out if a state has updated a particular soil survey and what the rules are for those exceptions. Another issue that we run into this year, just perfect timing for our SSURGO refresh this year, was problems that we had with connectivity and some network issues and domain issues on Web Soil Survey. That affected both the users of the Web Soil Survey interface and also those folks that were trying to download SSURGO data and use it on their desktop machines locally. We'll also discuss a few instances of some of the surveys that we know that will be changing this week or last week. In case you've already downloaded everything, there will be a few that you may want to go back and check on. And this slide just shows you the Web Soil Survey interface, how you get started. there's a little red arrow that points to the Start Web Soil Survey button. Some people would think that's fairly obvious, but I normally don't look for a button like that. So this just shows you how you get into the application, because in order to download data, you know, you used to be able to go to Soil Data Mart and get a listing of all the SSURGO data that was available and send in a request for that data. But it's different. If you haven't been into downloading our data for a couple of years, this is how you're going to do it. So you start Web Soil Survey with the green button, and that takes you to the Web Soil Survey interface. And if you just want to download a specific soil survey area or county, you will go to the Download Soils Data tab, which is that right-hand red arrow. And on the left-hand side, there's also pointing to the Soil Survey Status Map layer. So if you're using the SSURGO tools to download data in mass quantities, you'll definitely want to download the status map layer, which is a shapefile. You can also download as a PDF or as a JPEG for use in presentations or printing. But if you're going to use it in ArcGIS, it's a good idea to go ahead and download that shapefile. It's pretty big. I think it was like 100 megabytes, so make sure you've got room for it before you try to download the thing. This is actually the Download Soils Data page on Web Soil Survey, and you can see that there's several things that you can enter. You can change the name of the state that you want to download. You can change the date for the downloads. If you want to filter out and only display some of the newer surveys, you can change the date in the date field. And you can also change the sort order, whether you sort it by area symbol alphabetically or by date or by name. And then this is what the SSURGO status map looks like in the PDF download. So you can see for the most of the country we have complete SSURGO data available. In the lighter green areas, those are some surveys where we only have partial data. You really can't tell from this map how much data is available. In some cases, it's just a small area that we're missing because we were denied access or it's just not complete. But that still gives you a pretty good idea of what's available. Okay, the SSURGO Download Toolbox is a custom ArcGIS ARC tool. You'd run it like any other ARC tool. You'd have to download that toolbox, and we'll give you some more information on getting the tools here after a bit. And it was developed, the toolbox was developed for three primary reasons. And the first one was to make it easier for folks to download, you know, hundreds or even thousands of surveys. You can still do this manually through Web Soil Survey. You just have to click on each one of the links for each of the counties or surveys in your area of interest. But we have a lot of folks that do either have regional responsibilities, or perhaps they want to do analysis for a very large area for multiple states. And so the tools allow you to do that with just a few clicks of the button. It does take a while to run the downloads, anywhere from 1 to 5 minutes per survey if the internet is being good and Web Soil Survey is behaving itself. So it's probably something that you would run overnight or over the weekend. Second reason is to create what we call a gSSURGO geodatabase. And this is where we take all of the individual shape files that come in the original SSURGO product and all of the template access databases, and we combine those all together into a single geodatabase that covers the entire area. So instead of doing analysis on hundreds of soil survey area databases, now you can do it all in one. You can also do your mapping or create cartographic products much more easily with the file geodatabase. And then the third reason that we created this new gSURGO product is for the raster layer. We take the soil polygon layer and convert it to, the standard is a 10-meter resolution raster, which is a pretty fair representation at the scale that we normally use this data. And for those folks that are working on a statewide or regional level, that raster is really a great performance enhancer. It displays very quickly. Whereas if most of you have used SSURGO polygons, you know that they just kind of crawl across the screen as they're drawing. So this is a real benefit. A lot of our modelers and other folks really like to use that data. The description of the SSURGO download toolbox, that is what we call it, it's split up into 3 different groups or functional areas called tool sets. And the first set is called data management tools. And the data management tool is what we use to actually merge the original SSURGO data sets into regional or multi-county data sets that are still compatible with Soil Data Viewer. Since we're maintaining the shapefile format and the access database, the data that's created with these tools is still compatible with Soil Data Viewer, which is not the case for the gSURGO. And that's an important distinction. Those of you that don't have a good knowledge or don't have the tools to query the gSURGO database, then this can be an option. If you're only working with 30 or 40 counties or soil survey areas at a time, then this is just one option, is to merge those shape files. The second set of tools or tool set is called the download tools, and that's normally what you're going to start with. Even though I've got it listed as number 2, you're going to use the download tools first to download the SSURGO data to your local machine. And then once you've done that, then you can move into either the data management tools or straight into gSURGO tools. And there's a screenshot down here at the bottom of what the entire toolbox looks like, and then each one of the tool sets underneath that. Some of the requirements for using the gSURGO toolbox, or excuse me, the SSURGO download toolbox, it only works with versions 10.1 through 10.2.2 of ArcGIS. And so that means that those folks that for some reason are still on ArcGIS 10.0, probably because of your toolkit users, then you're going to be out of luck. I apologize for that, but there's enough differences in between the versions that we can't support anything before 10.1. Some of these tools will run from ArcMap, and there are some advantages to running them that way because you can do your selections using that soil survey status map layer. So you can actually see what you're downloading on the map, or you can see which databases you're merging by what you selected on the map. Some of the tools require internet access, and that would include all of the SSURGO download tools, or the individual download tools themselves. And then some of the gSURGO tools also require internet access because they're querying some of our online databases. The fourth requirement would be a SSURGO template database. You can download several different versions of the template database from Web Soil Survey. We have one that's for the U.S. It's called US 2003. So that's commonly the one that I'll use. It's the first one in the list, and I'll show you a screenshot of that here in just a minute, what that looks like. And then the final requirement would be the soil survey status map shapefile that I mentioned earlier, and there's a link to that listed below. But it's also, again, it's on the Web Soil Survey status page. And then, okay, this is Web Soil Survey, and this is the status map page. You just click on the little tab called Soil Survey Status, and it drops down a little menu. You can either pick the shapefile or the PDF or the JPEG. And it's just a straight download. Gives you a pretty good sized zip file. And I try to save these downloads, such as the shapefile or the template database, in a easy to find location. You don't want to bury that under My Documents or someplace that's hard to find. And then this is a screenshot of the Web Soil Survey download soils data page. And at the bottom of that page, there's another, I don't know, it's a tab, I guess, for downloading the template databases. And you can see that US 2003 database is the top one on the list. It's about 1.6 megabytes. And the download tools, actually, if you just download this database one time and save it to your hard drive, the download tools will make a copy of that for each survey that you download, copy it in. So instead of having to download that thing, that database, that 2 megabytes, 200 or 300 times, you just download it once, and then the tools will do the rest of the work for you and automatically run the import. So it's a real big time saver doing it this way. And so this is a screenshot of ArcMap. I'm actually running ArcGIS 10.1. And so you can see that I've got a couple of different layers in the table of contents. The most important one is that second one. It's the soil SA_A_NRCS, and that's the status map shapefile. And here I've colored each survey area a different color, and then I've selected 3 different surveys, all of them for Delaware. And so that's going to be kind of my demonstration. I'll just make a few quick, show you a few quick screenshots of what that looks like. Our tools are on the right-hand side, including the SSURGO download toolbox. So on the right-hand side, again, you can see I've highlighted the download by survey by map tool. And then when I execute that tool, this is what the tool interface looks like. Once you tell it to use the soil SA_NRCS shapefile as the survey boundary layer, it automatically recognizes that you selected those 3 surveys, and it goes to Web Soil Survey and finds the associated surveys and lists them in the choice list. At that time, you can either check them all or just check if there's only a couple out of that list that you want. You can just check those. And then you tell it which folder you want to download the SSURGO datasets to, and then where your template database is located. And it doesn't matter if it's just one survey or 3,200 surveys. They'll all show up in the list, and you can just click it and start going. And this is what the tool looks like when it's running. I always run these tools in foreground mode so that you can see the status messages. Here it's progressing a little bit. It automatically imports the data into the database, unzips everything, imports metadata, adds the MU name, map unit name, to the shape file. And one thing I'll caution you about, make sure you uncheck that little box that closes the dialog when successfully completed, because sometimes I'll give you a little bit of warning messages about things that are important to know about, and you won't see those if you check that box. It'll just disappear when it's completed. Other information gives you a progress bar, tells you how far it is importing the tabular data and overall progress. And then when it's completed, it should look like this. Shouldn't be any green or red messages at the end. Green messages would be warnings, and error messages would be in red. So if you see any of those at the end, it's a good idea to scroll back up through the messages and because you might find a more specific error message. And if they don't make sense, just go ahead and highlight all the text with your mouse, and then you'll have to use a Control-C to actually copy it. It won't let you right-click for some reason. And then just paste that text straight into an email, ship it to me, I'll take a look and interpret it for you. When the download is complete, you can see here I've got my 3 Delaware surveys. There's a folder for each one, and then underneath each folder or subfolder are your standard spatial and tabular folders and the metadata in a README file. And this is what the metadata looks like after it's been imported into this all polygon shape file. So these are all steps that you could run manually, but this is nice because it's a lot faster than you can do it manually, and it's consistent. It'll do the same thing each time. You don't have to worry about skipping a step. And another tool I'm just going to show you real briefly, this one. We're not going to go into a lot of detail on all the tools. There's not enough time in this hour to do that, so just going to give you a quick introduction. This is the tool that allows you to merge shape files from multiple soil survey areas. And I started out with the same status map. I had the 3 surveys selected and opened the tool. It automatically populates most of the information for you. And then once you click OK, it goes through really fast. It probably took like 10 seconds to merge these 3 shape files together. Where to find the tools. This is the last slide on the section on tools. Right now we've only got these tools posted on an NRCS GIS SharePoint. So it means that folks in Forest Service and universities aren't going to be able to get these tools right now. But our plan is within the next month or maybe 2 months to post these on our gSSURGO website, so everybody will be able to get to that. And so I've also listed there a fairly short URL for the gSSURGO, excuse me, the NRCS GIS SharePoint. So you go to that URL and then click on the left-hand side, the NRCS GIS site, and then go to Resource Shared Tools and Procedures and open up the gSSURGO folder. So I'll have some documentation there as well as a zipped up collection of the toolbox. And now I'm going to turn this over to Sharon.
All right. Thank you, Steve. That was a good segue because we're now looking at a screenshot from the gridded SSURGO public webpage. And at the bottom of the screen here, you'll see the URL for that. I know that many of you online today are probably going to be very familiar with some of this, and some of it's going to be pretty new to others. So just bear with us as we run through this. What I'd like to do is give you an introduction to our official gSSURGO products that we distribute only through the Geospatial Data Gateway at USDA NRCS. This is not a product that you're going to find on the web soil survey at this time. That might change in the future. How to download it, sort of what that data content is going to look like when you get there. Look at the formats and something state and CONUS Conterminous US tiles, as well as the national databases and so forth. In addition, we're going to take a look at this new add-on database called the National Value Added Lookup Table Database, which presently contains just one table called the Value 1 table, and we have plans for additional tables. We may just get to those this fiscal year as well. And these represent what we'll call pre-summarized or ready-to-map data, where we've done the calculations for you and presented a value or an interpretation at the map unit level. So I'll go through a little bit of exercises of using the value table to join, symbolize, and reclass to create a new raster, as well as look at a bunch of examples of how people are using the value table, Value 1 table, and the gridded SSURGO in some of their research and other applications. For those who are familiar with our soils.usda.gov website, if you want to find anything about soil geography, go to the soil survey pull down and just pull that down, and you'll find a listing for soil geography. And in that soil geography area, you will find the gridded SSURGO along with all of our other Federal Geographic Data Committee Circular A16, or our official soils data for the nation. This is produced in cooperation with the National Cooperative Soil Survey and all of our cooperators across the nation, as well as our field staff and regional staff within the agency here. All right, let's get going. So if you want to, you'll find out all kinds of good information here, introduction, release notes, and so forth at the gridded SSURGO website. And here are a few of those good things. The first is, and I highly recommend that you download it. It's a PDF. It's called the Gridded Soil Survey Geographic Database User's Guide. We first issued this a year ago and was 2 years ago, and it was reissued in April of this year. It's 81 pages. It's filled with very useful examples, actual ArcGIS 10.1 examples, I believe, for most part. There's also a 2-page gridded SSURGO fact sheet. You just want to find out what are they talking about when we're talking about gridded SSURGO. And let's see, and then where to find it. So if you need to go to the datagateway.nrcs.usda.gov site. And I find the easiest way to direct folks to find the gridded SSURGO is to click on the Status Maps tab with the big arrow there in the middle, and scroll down, because soils, as we know, starts with an S near the end of the alphabet, so we're often bringing up the end of a laundry list of data choices. So here we've moved on to where you will find the soils grouping in that status map listing. And right off the bat, if you go there today, you will find that there are 2 different years listed. One, 2015, for the soil survey geographic database, so the SSURGO data, the vector data that everyone worked so diligently to complete by the 1st of October. That was posted and released, I think, on the 10th of October this year, and so that is there. However, for us to create the official gSSURGO product, it takes a few months to compile, vet, and fully formalize the metadata. So we expect that the 2015 gridded SSURGO data sets will appear here on the Geospatial Data Gateway probably in December of 2014. So when that time comes, this will be changed. The 2014 will go to 2015, and all will be in sync. One of our goals is to be able to create the gridded SSURGO product as rapidly as possible. And we're getting very close to being maybe within about a 3 or 4 week period right now. So it's possible we could release this sooner, but no promises. The other thing we get a lot of questions about the gridded SSURGO product is, where do I get it? How much does it cost? How do I get it? You'll see here it's listed into our by state area, and also Conterminous United States. All of the downloads via the Geospatial Data Gateway are free of charge. They're done via FTP. CDs and DVDs for all USDA agencies are also free. However, if you're a private sector or otherwise, you will probably need to charge a small fee for the delivery. For the very large data, the Conterminous US or national data sets, there is a $250 fee for search and delivery, as well as you will need to supply a pristine hard drive. And most of that you can find out from our gSSURGO webpage, as well as here. Contact Rosemary Rivera at ftw.usda.gov for those bulk orders. All right, so now you've downloaded your gSSURGO, you've made an order, and what does this look like? What are you getting? So in the Windows Explorer, I've got a little screenshot here where the red arrow is pointing of what the contents of the zip archive look like once you extract it. And you'll find you'll have two things. So there's the gSSURGO_gwb.gdb, which is your statewide file geodatabase. And then there's a second GDB file or another file geodatabase called value_FY, and then followed by the year. This is a fiscal year 2014 example, so it says 2014. In addition, we also supply you with the PDF of the user's guide and a text file, which I'm trying to remember if that's the metadata, or Steve, do you recall if that's our metadata or it's another README file?
Yeah, I think this is kind of a standard gateway metadata, not necessarily state-specific, but for the data set.
Yeah, generic, yeah. So those are the items that you're going to find when you view this in the Windows Explorer. The first gSSURGO geodatabase will be the product that Steve has been showing you the tools about how we work very hard to create these products. So this is likely going to be all soil survey areas that intersect a state boundary. So you might get a little more than your state because we do not clip it. We take everything that's in the soil survey area that intersects a state boundary to create these state tiles. All right, now let's take a look at this in ArcCatalog. So when you open up that, it's going to create a soil subfolder for you, and in it you'll see the little databases here, gSSURGO, G_WB, in this case for a West Virginia example, as well as the value_FY 2014 geodatabase. And so this is what you can expect. The naming convention is usually that gSSURGO_G followed by the alpha FIPS code for the state. The exception is when we create the Conterminous US, which is all of the lower 48 states together, that will have a CONUS _, I think we use, 10 meter for the 10 meter resolution, 30 meter for the 30, and 90 meter for the 90 meter version. The value table database, however, is a national table database, so it can be used actually with any SSURGO or all SSURGO for the national collection. So it's very simple, lightweight database at the present. So we just bundle up a national table for use with all of individual tiles or the entire data set. If we want to now, let's just take a look into this value-added product that we're creating and look at the description tab in ArcCatalog to review the metadata. You'll find metadata for the database itself, and it's got the little infographic there of the lower 48 states. And then if you click on the file value 1 table, you'll find additional, more detailed metadata that will explain the definitions and units of all of the table content. All right, so what is in this thing? Based on work that we've been doing first in prototype mode and then more formally over the last 3 years, we've identified about 7 themes here that seem to be our most frequently asked for queries or calculations, mostly to satisfy the GIS simulation model community. And by simulation modeling, it can be everything from hydrologic modeling to economic modeling to climate change modeling to weather prediction. So it's many, many different types and purposes for this. So in order to respond to that in a more consistent and reliable fashion, we prepared some calculations. And this value 1 table contains 57 pre-summarized or ready-to-map attributes derived from the published Soil Survey Geographic database or your old standby, the SSURGO database. These are updated with each fiscal cycle. These include soil organic carbon stocks, and the units here are grams of carbon per square meter, available water storage expressed in millimeters, and the first two have a red star next to them, and if you look over to the right-hand side, red star means that they are prepared for a set of standard layers and zones, and we'll review those shortly. In addition, we include crop productivity indices, and these are map unit weighted averages. I think for the major earthy components, I think is the way we express it. And these include indices for cotton, wheat, or small grains, and then corn and soybeans, and then a best overall value. In addition, one of the intermediate calculations included is a crop root zone depth estimate. Again, this is a weighted average for earthy major components for the map unit. And within that crop root zone depth, we provide the available water storage capacity. This is expressed in millimeters. And from that information, we further classify it out into all of those map units that would have less than basically 6 inches or equal to 6 inches or 152 millimeters of available water storage, and we class those into drought vulnerable or not drought vulnerable, just kind of a binary map. And lastly, we've included something on the wet end of the spectrum, potential wetland soil landscapes, which is expressed as a percent of the map unit, which really I can point you to a full-blown set of rules for that, but it includes the percent of the map unit that is in a hydric soil. And if it's for all other components or map units that are not evaluated or designated as hydric, we search out some other terms that might hint at whether or not some of these soil landscapes could be wetlands. Maybe they're drained or undrained, flooded, protected, dredged, some long list of terms. All right, so let's look at some of these standard layers. But first, let's join them off. What we end up doing is you open up your ArcMap session, and the examples I'm going to show you, you don't need any special extra interfaces or software. This is just plain old ArcGIS 10.1 I'll be showing you here. First, we add the map unit raster, 10 meters for West Virginia in your table of contents, and then we go to the value table database and we bring in the value 1 table. We begin to affect a join, and we will rely again on the old standby, the map unit key, which is a unique text field that's present in both the map unit raster as well as in the value 1 table. So when you get those put together, you'll notice that all of a sudden your map unit raster now has some more extra columns on it. So to the right of the red arrow here, you'll see now there's columns called AWS 0 to 5, AWS 0 to 5 to 20, 20 to 50, and so on. These are some of those standard layer values that we'll review. All right, as I mentioned earlier, both the soil organic carbon and the available water storage will be presented according to 6 standard layers or 5 standard zones. So 0 to 5, 5 to 20, 20 to 50, 50 to 100. These are kind of like standard slices through the soil. 100 to 150, which is often a de facto effective rooting depth. And then if we do have any depths reported below 150 centimeters, those are also in that slice. In addition, we have 5 standard zones. The first is 0 to 5 is the same as the standard layer above. However, then we expand that to 0 to 20, and we've added 0 to 30 in there, and 0 to 100, and we'll use the 0 to 100 available water storage in our examples that follow, as well as the entire full reported soil depth. All right, so let's return. Now we'll work on classifying and symbolizing the value 1 column available water storage for the 0 to 100 centimeters, keeping in mind the units are in millimeters. So you can go ahead and classify, and we'll go with 5 major manual breaks here. I like to use the 152 as a break because that is the threshold we think of as potentially identifying droughty soils or drought vulnerable soil landscapes. So here we are. We've got them classified. So the tan color would be a 0 value, nothing at all, which you may find for some miscellaneous land areas or map units that have very little earthy materials in them. 1 to 72, it is approximately the same as up to 3 inches. We go from 72 to about 152, it goes 3 to 6 inches. And we use the next one, 6 to 9 inches, and then basically greater than 9 inches available water storage. Oops, wrong arrow. Let's go the other direction. And then here is the result that we have after we classify the West Virginia map unit raster 10 meters. You'll see the majority of this map is in the orange and yellow area, so they have that less than 6 inches or less than 152 millimeter area. All right, now, as soon as we join off the tables, the next question we're often asked is, I want to create a unique raster based on one or more of the columns that are in the value table. How do I do that? Well, Steve and I know, and the team that we'll introduce you to later know, there are many ways to do this, but this is one that I find is pretty straightforward. I like to recommend using a lookup tool. In this case, that is found within the 3D Analyst toolbox. It's the one I like to use. It's simple. I like simple things. And we use it to reclassify the map unit raster 10 meters that's got that joined value 1 table on it. And we're going to create a new raster. So this is what the tool looks like when you open it. There's an input raster, which is your map unit raster 10 meters. There's going to be a lookup field, and we haven't chosen it yet, so the default comes up as the internal value. And then you're going to select a place to put the result, the new raster. So you'll give it a path and a location. And for the tool help, always go there and read more. And because there's wonderful examples in Python down at the bottom, most of these that you may want to use in the future. So you can read about what's actually happening here. And then you can go back and go ahead and you'll see when you do your little pull down for the lookup field, you'll have many choices. And so you'll choose 0 to 100 and go ahead and say OK. And this raster took, I think, in my laptop computer, which is a pretty respectable computer, it took about 12 minutes to calculate. And often you'll need to go back and build your raster attribute table or run statistics and stuff to make the raster behave properly. So what you see here now on the screen is just the default for that new raster that I built from a single column with its default symbolization. So the darker, the greener colors are higher and the tan colors are lower in value. All right, well, we're going to look at a few examples here of some of that we worked so hard with Steve's tools to create these data. And now we want to see if we can put them to work and take a look at these. So we're going to take a look at some examples from the Mid-Atlantic region. And here we're looking at southeastern Pennsylvania. If you look all the way to the right-hand side, this dark blue area is part of the Great Valley in Pennsylvania or Lancaster County and so forth. Northern Maryland and eastern West Virginia beneath there. So right away you'll see that we have a hillshade on beneath the root zone, available water storage capacity. These are the same breaks that we used in the example. The tan color is 0 or very low. Low is 1 to 3 inches. Moderate, low is shown in yellow. Moderate in orange, 3 to 6 inches. Green, 6 to 9 inches. And very high is the blue area. So right away, if you're familiar with the Ridge and Valley province of the this region, you'll notice that the higher values are showing up in the valley bottoms, which are often limestone residual soils, or they have nice loamy colluvium adding to their capacity to store and release water to the plant root. Here's the same information. We got a little different classification for the root zone available water storage, again in millimeters, for the state of Kansas. This is a fresh product. I think Steve just got this done yesterday for the fiscal year 2015 data. And the green areas are higher, in the water storage values if you look at the legend to the right, and the red areas are the low areas. Keep that pattern in mind. We're going to take a look at the Conterminous US now, and we've turned on the drought vulnerable soil landscapes column from the value 1 table. This is that binary column that if you have 6 inches or 152 millimeters or less available water storage in your crop root zone, you're going to have a red color on this map. This is also, we've supplemented this is fiscal year 2014 gridded SSURGO with the published, a gridded version of the StatsGo 2 data set for infilling in the western portion of the nation to give a more realistic view of what might be out there. Now we're going to zoom into a little part of central PA, again in the Ridge and Valley province. It happens to be the northern Appalachian Ridges and Valleys in MLRA 147. And we'll zoom in and see what that drought vulnerable soil landscape looks like close up. The scale bar here is about 9 kilometers. The dark red areas are shown on top of just a gray analytical hillshade. And I think we have here also the location of the Shale Hills Critical Zone Observatory watershed, which is in the upper Shaver Creek, and I think that's a 12-digit HUX, so you'll see kind of draped across this landscape too. So if we look at that, and then we go ahead and switch over to the root zone available water storage, you'll see that that pattern pretty much reflects the orange and yellow areas here. Things that are orange, yellow, and tan will be anything less than 152 millimeters. It gives you a good view of kind of where you could expect productive soils, at least based on physical character, such as rock fragment content, the fine earth fragment or fine earth fraction, and organic matter content, as well as the root zone depth. And here we have a map for the exact same area showing rooting zone depths in 5 colors. The tan colors or the brown colors are more shallow rooting depths. The darker brown is going up to about a half meter to a meter in depth. Then we switch over to a pale blue for greater than a meter to 1.5 meters, and the darkest blue color showing you where they exceed 1.5 meters in depth. So both the physical character and the rooting depth will be constraining that root zone available water storage capacity. And now to finish out the value table, we'll show you an example of what the potential wetland soil landscapes looks like for that same region. Here we have this expressed as the percentage of a map unit. So we have 5 categories. The more intense this kind of pinkish brown color, the greater the percentage of the map unit that might be considered potentially a wetland soil landscape. So we can see again on these colluvial foot slopes, you'll see some of those where we have perched water tables and so forth coming in, that you might have potential here for some wetland springs and so forth showing up in those ridge and valley landscapes. For the more detailed rule set, you can check out the appendix in the Gridded SSURGO User's Guide, as well as in the metadata itself. All right, and not to quite finish out the Value 1 table, we wanted to also mention and illustrate some of the national commodity crops productivity indices. Here we have an example for small grains in Kansas, again, fresh off the press with fiscal year 15 data. And this is the result of the work principally of the National Soil Interpretation Staff and Bob Dobos and Michael Robotham and others that led to this something called, it's basically a fuzzy interpretation and model within the NASA's software. And you can read all about it at this URL at the back and at the bottom of the slide. And let's see here. Also, in this map, the green colors indicate high productivity, red, low productivity. And also Bob Dobos, if you don't already know Bob, you can also email him with information or questions about this. And in that light, here's just one example where we're looking at application of using the gridded SSURGO along with a NASIS-generated interpretation for soil habitat for the valley fever fungus. So on this map, the red and orange colors indicate a much greater likelihood of encountering a habitat where you might have trouble with this valley fever fungus becoming prevalent and affecting the health of individuals. And then where it's yellow and green, it's much less likely. So here it's, I was going to say, if we would have relied on vector SSURGO to create these maps in the timeline that we're often asked to, we would probably never be able to deliver. But the gridded SSURGO, as Steve pointed out, allows us to make these things much more rapidly, review and adjust our rule sets quickly and make better maps in the end and more responsive maps. So if you do have questions about this particular application related to valley fever, I've given Bob Dobos's email there for follow-up, and he's consented to do so. All right, and just to acknowledge our team that's been in development with this over the last, I would say, almost going on 5 years now. I've listed them here, but many important individuals from the National Geospatial Center of Excellence in Fort Worth, Texas, the National Soil Survey Center in Lincoln, the folks at USGS with Arrows Data Center in Sioux Falls, South Dakota, all of our field and regional soil survey staff who, of course, create the data in the beginning, and our NCSS cooperators across the nation. So Steve, I think I'm done, and I think we're ready for questions if we have some.
All right, and again, you can enter a question in the Q&A tab on your screen. And let's see what we have for questions. First one is, what about soil survey areas joining these new areas? Can they be refreshed as an exception? Steve, that was something you were covering. Yeah, I think, no, not normally. Otherwise, there wouldn't be any end to it. You'd end up refreshing the entire country. Okay, this one may be more of a comment. In case any field employees are listening, you may want to mention that they should check with their NRCS State GIS coordinator before trying to acquire all this data on their own. This could head off any duplication of efforts already taking place in many states. Yeah, that's a good point that Chris makes. I think in a lot of cases it might be a state GIS specialist or a regional GIS specialist, or in some cases I think, it might even be an assistant state soil scientist that may be accumulating some of this data. So it's always a good idea to check around because it is a fair amount of work and use up a lot of bandwidth. All right, the next question is, will SSURGO tools work with ArcMap 10.2? Yes, they will. And 10.2.2, that's as far as we've tested. And it's just a comment that this person's a Forest Service employee and they are able to access the SharePoint site with no problems. Good deal. Must be USDA wide then. Do gSSURGO file geodatabases only contain raster data or a vector version also? They contain the vector and the raster and all of the attribute tables, so everything is in one package.
Yeah, that's the nice part. You get everything.
Okay, another question. May we beta test the SSURGO download tools? I could really use this tool. Possibly. You can contact me and I'll see what I can do. Right now we had to make a lot of changes at the last minute because of the issues with Web Soil Survey. I had hoped to have finished the documentation on them by now, but that kind of set us back. Hopefully within the next couple of weeks or months, we'll definitely have those posted for public use. And a question about, will this slide presentation be available to us? Yes, I have a videos and webinars page
that in addition to linking to our National Soil Survey Center YouTube channel, also has the PowerPoints posted there as well. And they're posted by branch. So if you scroll down through the page, the videos and webinars page, you will find these, and I'll have this posted, probably by the end of the week. And a follow-up question from earlier, but the initial soil surveys and all surveys they join need to be able to join once they are finally ready to be SSURGO certified.
Yeah, ideally, but at some point we have to quit and call them good enough and get them posted.
Next question, is the downloadable JPEG georeferenced?
I cannot remember if I created that georeferenced or not. I can check on that and find out, or just download it and try it, I guess.
Is that
Next
for the
question.
soil survey area?
Or the status map, I think she's
Okay.
talking. Downloadable JPEG. Yeah, I think she's talking about the status map.
Next question, is there any file structure we need to follow for the gSURGO tools to work? The tools look for specific places where the files are located. I can't make the map rasters tool to work.
Milton, yeah, email me on that if you're still having some issues. They do look for a specific file structure. The tools are designed to, begin with the download tools. They create a certain file structure, and then the rest of the tools after that depend on that specific file naming and folder naming.
And he was talking about the map unit raster tool.
Yeah, I think it does look for the MU polygon feature class.
Next question, maybe this was covered, but are the value algorithms that are not part of the standard export, like organic carbon, potential wetland, etc., published in somewhere or can be found in NASA's reports?
This is Sharon. Right now we're working on a publication that does document all of this. We tried to do as good as we can in the metadata right now. We can follow up with most of that. I think, I don't believe we have these in the NASA's reports. Do you know, Steve?
Well, other than like NCCPI and...
Yeah, there's a little bit post-processing, but yeah, NCCPI would. Mm-hmm.
And Dobos has got some of like the root zone available water supply, and some of those others are scattered.
And the root zone depth. Mm-hmm.
Root zone depth are in NASA's.
Yeah, I should have made mention that we're working, hopefully, and our team does involve like Paul Fennell and a bunch of other folks who are kind of riding herd on some of these things, but to do some kind of harmonization of the SQL scripts so that we do have some standard SQL scripts that could be executed on the soil data access facility consistently against the published data. So we're working toward that goal. In fact, the Value 1 table has been documented and submitted for inclusion into the soils data model or data dictionary at this point. So it will be undergoing review at this time. So all of that will have to be fully documented.
Okay, another question. The soil access database name changed since fiscal 14. Is it critical?
Well, the name isn't critical, but the version of the access database is critical, and that's why I pointed out where you would download that. It has to match the version of the data, SSURGO data, in order for the import process to work properly. Hopefully that was the question.
In the tools, was there a tool for combining .mdb files as well as vector survey?
Yes, Pam, there is. It's part of the data management tool set. There are tools specifically for merging access database.
Are alias names set up for the 57 attributes in gSURGO Value 1 table?
I don't think so. Are they, Steve?
No, I mean, they're not I don't think we developed those. They're not, the alias names for the SSURGO tables are established standard aliases, and I don't think we've built those for the value 1 table. We could.
Well, we have long names in the appendix and in the metadata. I think we include the long names, if that helps, plus the full definition. The appendix of the gSURGO User's Guide.
Yeah, it's a wide, really wide table, so I think we were a little bit reluctant to put those aliases in there because ArcMap and ArcCatalog ArcMap by default displays those aliases, and the table would be like 4 or 5 feet wide on your screen if it displays those.
We kept them short so that it'd make it easy to use with standard ArcMap tools.
Does the metadata include information about aggregation methods used to create the gSURGO raster layer?
There's a brief mention of the aggregation method. It actually, currently we're using the majority combined area method and the polygon to raster command in our toolbox.
And our last question, I know we've gone over a little bit, but can the versioning concept be applied to gSURGO as we move with STJR and disaggregation?
Well, I can try. I would say yes, but of course we're only working at the map unit level for versioning. We could and we research a little bit more down to the feature level for this, but definitely these archives could be very good historic snapshots to look at forward or backward for progress.
Excellent questions.
Yes.
Feel free to email us. I know we went through things pretty rapidly today, but go ahead and email Sharon or I if you have questions you didn't have time to get answered today.
And I think I'll work with Sean to add a link to the gSURGO web page, public page, for all of the video and PowerPoint so that it's easy to find them for those who might be interested. And Sean, do we know how soon those will be ready?
No, I hope to get things posted by the end of the week.
Okay. Well, by next week maybe we can get that done. So.
And, so I want to thank everybody. We did go over our time. If you do have a question that we didn't get to, please feel free to follow up with Steve or Sharon. And I appreciate your time and attention.